All right, everyone, you should be at page 35 in your Walsh book, and we're going to go over the homework. So for number 1, you have congruent side, you have another congruent set of congruent sides, you have a third congruent set of congruent sides, and we know that SSS together is one of our theorems, so we know that triangle ABC is congruent to triangle that's 1, 3, 2, DEF is also 1, 3, 2. So DEF, because of side, angle, side. Nope, that's not true because it's 3 sides. Because of side, side, side. All right, so let's go on to the next one here. We are given a set of congruent sides. We're given another set of congruent sides, and we are given a congruent angle. We know that ASS and SSA are not congruence theorems, so we're going to look to see if this is side angle side. Well, in side angle side, the angle has to be the included angle. So this would only be side angle side if you knew about angle G and angle J. So in this one, you cannot determine congruence. Now, that doesn't mean they're not congruent, but it means you can't necessarily say that they are. All right, so then we went on to number 3. And for number 3, it says based on the information, is ABD congruent to CBD? Well, they give you a side, set of congruent sides there. They give you an included angle, or they give you an angle, and then this is a part of both triangles, so it's also going to be a congruent side. So it looks like we'll have side, angle, side, side, angle, side, and it is true that these ones end up being congruent because of the side, angle, side congruence theorem. All right, looking at the next one, so we have STU, STU, and VWX. It tells us that S is the same as V. It tells us that T is the same as W. And that ST is the same as VW. So they give us 2 angles, and they also give us a side. So now we need to think about whether it's angle, angle, side, or angle, side, angle. And the difference between these is whether or not the side is a corresponding side or whether it is an included side. Well, when I look here, that side for each of these is included. So these are going to be congruent according to angle, side, angle. Number 5, again, we're going to draw these out. So that's M, N, O, and P, Q, R. So that's going to tell me that O is the same as R, and that MO is the same as PR, and NO is the same as QR. So here we're given a side, and an angle. This doesn't exist, so we want to see if this is side, angle, side. So we need to know if that angle is included. Well, this is a side, an angle, and a side with the corresponding side, angle, and side. So these are congruent according to side, angle, side. All right. On the next one, we've got GHI and JKL. And it tells us that G is the same as H, and that HI is the same as KL, and that J is the same as K. Well, right now it tells us that G and H are the same as each other, and J and K are the same as each other, but they're not necessarily the same across the triangles. So the only thing that these have in common is one side length. And one side length is not enough to prove congruence. What we could say is these are both isosceles triangles, because since they each have 2 of the same angle, we know that this side is going to be the same as this side, and we know that this side is going to be the same as this side, but we don't necessarily know that those angles are equal, even though we could end up trying to figure that out. This does not give us enough information, so we would say not enough information to determine congruency, because again, they'd have to tell us that we'd have to have a single arc in each one and a double arc in each one. All right, so 7 and 8, they're just asking us to think about the relationship that happens here. So here we have some options here because we have two angles. So if we're looking at both of these here, you have that A is the same as F, so you've got an angle that's the same. You've got that C is the same as B, so that's another angle that's the same. And then you also have that AB, so a side is the same as, what letter is that? GF, and that AC is the same as EF, so we also have two sides here. So we've got some things to consider here. So anything that includes the letter S twice, the only one there is side, angle, side. So let's go to figure out whether side, angle, side works here. We need congruent sides, an included angle, and then another side. So this would be a side, an angle, and a side, an angle, and a side. So these would be congruent according to side, angle, side. But if I have two angles in a side, this could also be angle, angle, side, or angle, side, angle. So let's think about this one here. Well, in angle, side, angle, I have two given angles that are the same. So that would be G and F and A and B. And then the side length in between them that's included is also the same. Well, that is one tick mark, that is one tick mark. So these are two congruent angles with an included side that is congruent. So this is also angle, side, angle. All right. The last one, it's actually technically could be another one because angle, angle, side says that there are two angles and a non-included side. Well, I've got two angles here, and then I've got two angles here. Well, the non-included side is across from the one-arced angle. The non-included side here is apart from the one-arced angle. So this one also could be angle, angle, side. So given that much information, basically you're given everything here except for one triangle or one angle and one side length. You've got lots of different options. All right, so for angle 8 here, they tell us that we have two sides. So that's two sides. They also give us an angle. Well, we know that SSA is not a theorem and ASS is not a theorem, so we have to see is this side, angle, side. Well, in side, angle, side, it has to be the included angle. Well, the included angle here is angle V and angle Z. And I don't know anything about angle V and angle Z. So here I have to say not enough information. Some of you might be tempted to try to use hypotenuse leg. Well, first of all, they don't tell us this is a right triangle. There's no right triangle indicator here, so we can't use our eyes to make that assumption. And also, if it were a right triangle, they still didn't give us anything about the hypotenuse, so we couldn't use hypotenuse leg. All right, next one. I want to know if the Kim family owns the same size plot as the Reed family. So the Kim families is IKD. So the Kim families is I to K to D. So it's that one right here. And the Reed families is K to D to E. So that's K to D to E. E. All right, so in this one here, they give us a congruent. So we have a side that's congruent. We know that IK is the same length as DE, so that's a side. We also know here that this piece, K to D, we know that that piece is congruent to itself. So we also have another side that's the same.
Now here, we don't know, this is made up of this side length here is a 3-tick, but that's the 3-tick is just this part here, and it doesn't tell us anything about this part, so I don't know anything about this side. So now they don't tell me about this angle, they don't tell me about this angle, they do tell me about one angle here, they tell me it's the same as this angle here, so they do give me an angle. So here, this is, again, SSA is not a theorem, ASS is not a theorem, so I have to see if this can be side angle side. Well, in side angle side, I need to have an included angle. Well, I don't know the length of this side, so the angle is made up of a known side and an unknown side. So that is not an included angle here. So here there is not enough information. Then for number 10, I'm considering the Kim family. Nope, that's them, the Larson family and the Rodriguez family. So when I go to create, I'll pick a new color here. So the the Rodriguez family is up here. And here I have a 3-tick, a 3-tick, and a 1-tick. And then the Larson family is here. And here I've got a 3-tick, a 3-tick, and a 1-tick. So this is the Rodriguez family. This is the Larson family. So I've got a 1-tick and a 1-tick. So I've got a side that's the same. I've got 2 3-ticks on each one. So I've already know that I've got side, side, side. Well, I also have a side, an angle, and another side. So I've got 3 ticks, 2 arcs, 3 ticks. I go up here and I see 3 ticks, 2 arcs, and 3 ticks. So this is also side, angle, side. So either one of those there would prove that they are congruent. So hopefully that's helpful. If you have any other questions, of course, email me and let me know. But now we're going to move on to today's lesson, which is proving the vertical angles theorem.